This is a recording of a walkthrough of OCR Paper 2 Foundation from June 2023. This is the non-calculator paper. Okay, so write down the percentage of the circle that's shaded. A quarter, 1 out of 4 shaded. What's a quarter as a percentage? It's 25%. Shade 2/3 of this rectangle, so 2/3 means 2 in every 3. So out of these 3, I'll be shading 2, and out of these 3, I'll be shading 2. So 2/3, you can see, is the same as 4/6. Work out 20 minus 16 divided by 2. This is a BODMAS, so you might call it BIDMAS question, where the order of the operations matters. So if you were looking at BODMAS, brackets, powers, division, multiplication, addition, subtraction. Division appears first. So division is a bit you work out first. 16 divided by 2 is 8. Keep the same order though. 20 take away 8 is 12. You mark that. Insert one pair of brackets to make this calculation correct. So I'm just going to do this calculation first without any brackets. So you would work out 3 times 8 is 24 first. And we'd have 2 plus 7 minus 24. So with the addition and subtraction, you kind of follow the same order. 2 add 7 is 9. 9 take away 24 is not 34. So let's just think about where we could put these brackets. If I put them here, wouldn't really make any difference. 9 minus 24 again, which is not 34. So I just move my brackets along one space each time. Let's try them here. So brackets in your BODMAS order is first. 7 take away 3 is 4. Then we'd have to work out the multiplication next, because it appears before addition and subtraction. 32. 2 plus 32 is 34, so your bracket should have been around your 7 and your 3. We work out how many customers there are in this sample. So we just 25 customers were very satisfied. So we've got 24 here, 12 were satisfied. And this is between 8 and 10, so it's 9. 8, 36, 45. Okay, the store manager decides to display the results in a pictogram, complete the file row. So there's 24. And this would be 12. So let's work out what each of these shapes represents. 24 divided by 4 is 6. So each one is 6 customers. Now we need to fill in the dissatisfied, which is 9. So we need 1. And then we've got another 3. So you need half of one of these. You have 1.5 shapes there. Might be the other way around for you. That's fine as long as you've got 1.5 squares. Right, so we're converting an improper fraction to a mixed number one here. How many 5s go into 17? 5, 10, 15, it's 3, which is how they got this number. We got to 15, what's our remainder to 17? It's 2. So it's 3 2/5. Change this to an improper fraction. So we want to look at how many quarters we've got all together in 2 wholes and a quarter. 2 times 4 is 8, plus 1 is 9. And it's quarters still, so 9 quarters. 4/7 take away 5/14. So when we subtract with fractions, we need a common denominator. What's the lowest common multiple of 7 and 14? It's 14. So I want to make my fractions both out of 14. This is already out of 14, so I can leave as it is. How do I make 7 into 14? I multiply it by 2. Because I'm making it into an equivalent fraction, because I've multiplied the denominator by 2, I need to multiply the numerator by 2. Now we can subtract these fractions because we've got a common denominator. Subtract your numerators, leave your denominator the same. Two different ways you could approach this. So when you're multiplying fractions, you just multiply the numerators and multiply the denominators. In fact, I'll just do this one way, I think. So multiply your numerators, you get 30. 2 times 15 is 30. 5 times 16. Well, 10 times 16 is 80. So 10 times 16 is 160. So 5 times 16 must be 80. And then you simplify it, divide both sides by 10, you get 3/8. Solve, what's x? Opposite of divide by 3 is times by 3. So I'm going to times both sides by 3. You times the left-hand side by 3. It just reverses the 3, so leaves us with an x. Times the right-hand side by 3, we get 18. Divide both sides by 2 here, because this means 2 lots of x. X times 2, I need to make it into 1. Divide by 2, which gives you x is -7. Alex is 1.34 centimetres. We want our answer in centimetres. So 1 metre is 100 centimetres. I'm going to multiply this by 100. Okay, so find out how much taller Alex is than Gabby. 134 minus 95. So it's 5 to 100. Another 34 would give us 39 centimetres. Okay, next one. Order these from smallest to largest. We need consistent units first. We could either convert them all to millilitres or all to litres. I will do both. 1 litre is 1,000 millilitres. You need to know that conversion. So divide this by 1,000, you get 0.25 or 250 litres. I just want to put them all in millilitres too. 1/5 is the same as 2/10. 2 divided by 10 is 0.2. So this is 0.2 litres. I'm going to times it by 100, sorry, by 1,000 to get into millilitres. So it would be 200. Times that by 1,000, 300. And times this by 1,000, 199. So it's up to you if you want to look at your millilitres or your litres to order them. This is obviously the smallest. Then it's this one. This one. And this one's your largest. ASME invests £700 at a rate of 2% per year, simple interest. So every year they'll be getting 2% of £700 as their interest. Work out the interest ASME receives after 1 year. So we want to work out 2% of 700. Let's get 10% first. Without a calculator, again, 10% is your best option. Divide it by 10, which is 70. 10% 70, I'm going to get 1% next. We divide this by 10, divide this by 10, 1% 7. Let's now get 2%. 2% is double 1%. So double this, 14. So it's, every year it's £14. Work out the value of ASME's investment after 3 years. Every year they're getting £14 interest. So what's £14 times 3? You might have worked that on your head, £42. But what's the value of the investment? We've got to add back on a £700 as well. Increase 20 by 15%. Increase means make 200 bigger by 15%. Let's get 15% of 200 first. Okay, 10%. 20. 5% is half of 10%. So it'll be 10. So 15%. Just add these together. So we need to increase 200 by 30, so add them together, 230. Okay, I'll need to snip this over, and I also we'll need a protractor. I haven't got a ruler to do this, but I will give you the answer from the mark scheme. So I'll just read that out while I'm waiting for this to load. If you measure the distance from town A to town B, you should get anything. It's going to allow anything from 6.8 to 7.2 centimetres. But then you've got to convert it into kilometres, so times it by 10. So for an answer anywhere between 68, so they've given their answer as 70 kilometres here, but they will allow anything from 68 to 72. So if you've got anything between 68 and 72, you would have got the 2 marks there. Okay, let's see if it's loaded. Okay, I'm gonna have to describe, I haven't got a ruler, but I have got a protractor. I have to describe some of this. Just bear with me one moment. So we've done part A. Town C is 55 kilometres from town B. So once we've figured out kind of the position of it using the bearing, you would have to draw a line 5.5 centimetres, which I'm not going to do. I'm just going to show you the bearing part. So just remember your 3 rules of bearings. This is a bearing question. 3 rules of bearings. You always start from north, always go clockwise, and always needs 3 digits. Town C is in a bearing, Town C is 55 kilometres from town B on a bearing of 330. It's on a bearing of 330 from town B. So there's 2 different ways you can do this. So don't forget, bearings, we go clockwise. So we have to start at north and go clockwise. But can you see on this protractor, we only get up to 180. We need to go all the way around to 330. I'm just going to join town A and B together. Don't have to do this. So let's think about what the anti-clockwise bearing would be, the anti-clockwise angle. You've got 360 degrees, make a full circle. 360, take away 300. Take away 330 is 30. I'm going to measure 30 degrees from the other side. So 30 degrees is here. I'm going to join a point from here to here. Okay, so can you see this bearing here? The angle would be 330 degrees from here to here. That amount of turn is 330 degrees. We've got the bearing part, but town C is 55 kilometres from town B. So you'd measure 5.5 centimetres. Wherever 5.5 centimetres is, you draw across. Sorry, I can hear an alarm going off in the background. I'm just going to pause the recording and just turn it off. Sorry about that. It was just really annoying me in the background. I couldn't concentrate. Right, next question. Question 10. Okay, so Hero and Ling work in a restaurant. Hero's paid £9 per hour. Ling is paid £10 per hour. 1 week, Hero works total 30 hours and Ling earns £50 more than Hero that week. Work out the number of hours that Ling worked. Okay, so let's start by working out. We know Hero worked 30 hours and he gets paid £9 per hour. 9 times 3 is 27. £270. 9 times 30 is £270. Okay, Ling earns £50 more than Hero. I'm going to add £50 onto this, which gives you £320. So Ling earns £320 for the whole week. Divide it by 10 because they get paid £10 per hour, which is 32 hours. Okay, work out this without a calculator. So what's the cube root of 64? So you might want to do this as trial and error. 1 cubed is 1. 1 times 1 times 1 is 1. 2 cubed is 8, because 2 times 2 is 4, times 2 is 8. 3 cubed is 27. 3 times 3 is 9, times 3 is 27. 4 cubed. 4 times 4 is 16. 16 times 4 is 64. So the cube root of 64 is 4. Times half squared. Half squared, we've just got to square everything in our bracket. 1 squared is 1, 2 squared is 4. What's 4 times a quarter? So there's a couple of ways you could do this. I'm going to maybe change 4 into a fraction by sticking a 1 at the bottom. Multiply your numerators, multiply your denominators. 4 divided by 4 is 1. Okay, Sasha's trying to remember a 4-digit PIN number. Sasha knows it has the following digits and that the first digit is 9. Write down all the possible orders for Sasha's 4-digit number. We know the first one's 9. That's always going to stay as 9. So I'm just going to put that one as my first option. I'm going to swap my 2 last numbers around. So those are the options for 3 following. I have 9327, 9372. I'm going to then follow the 9 by using a 2. Then you could have 37 or 73. And then I'm going to put 7 next. So you could have 23 or 32. So there are 6 different possible combinations. Sasha tries one of these orders at random. Write down the probability that the last digit of the PIN number that Sasha tries is 2. So that's the last digit 2. This is the last digit 2. So it's 2 out of possible 6. Could have used that as your answer. You could have simplified it to a third. Either of those would give you 1 mark. Okay, so Ryan is making a sequence of patterns using counters. So you've got 3 counters here. Then I'm adding a 3 to get 6 counters. And I'm adding a 4 to get 10 counters. And I'm adding a 5 to get 15 counters. So can you see the pattern here? Adding 3, adding 4, adding 5. What are we going to add for the next pattern? 6. I still have enough counters to make pattern. He's got 80 counters in total. He says I still have enough counters to make pattern 5 and 6. Is he correct? So pattern 5, we've worked out it'd be 21. What about pattern 6? We need to add 7, which is 28. So well, let's just add all these counters together and see if it's less than 80. So 21, add 28. And I'm going to combine those to make 25. So 5, 14. 2, 4, 6, 7. So we've got 74 in total for 3, 4, 5, and 6. Add 6 gives you 80. Add another 3 gives you 83. So no, because he needs 83. Okay, so looks like a complicated one. So pattern 1 and 2. 3 add 6, yeah. Pattern 2 add 3. 6 add 10 is 16. Pattern 3 add 4. So pattern 3 is 10. Pattern 4 is 15. Now I'm not sure if you'd notice this, but I can see these are square numbers. 1 and 2 is 3. And 3 squared is 9. Well, okay, right, okay. 2 add 3 is not 4, but this is like... So okay, so 1, 2, 3, 2, 3, 4. And 4 squared is 16. 3, 4, 5, so it's just your next number. So it's all about pattern spotting here, and 5 squared is 25. If I looked at the next one, it would be pattern 4. If I looked at the kind of pattern here in the numbers, pattern 4, pattern 5, 6 squared is 36. That's how it works. And so then it's asking you to like think ahead if you had 144 in your total counters column. Square root of 144 is 12. 12 squared is 144, and it'd be 10 and 11, wouldn't it? Pattern 10 and 11. So what's K? It's 10. It's quite a tricky one, that one, so don't worry if you didn't spot that. I don't imagine many people getting that correct. Okay, next question. £50 to spend, 6 key rings. So 6 times £3.50. So you could do this in a number of different ways. I'm going to do 35 times 6, and then I'm going to put my decimal point back in. 6 times 5 is 30. 3 times 6 is 18. 90, 20, 21. Decimal point would go there, so £21. You might have worked it out slightly differently. 2 wallets at £7.50. Well, double £7 is £14. Double 50p is another pound, so £15. So show all your working. So what's our total? So what's 21 add 15? £36. £50 to spend. So what's 50 take away 36? You can actually work this out mentally and just put your answer in, or you could have a column subtraction here. But £4 to 40, another 10 to 50 would be £14. Okay, so each one's £2.99 each badge. I'm going to just round that to £3 just for the time being. So 3, 6, 9, 12 would be 4 badges, right? So you can get 4 badges. How am I going to show that in a calculation? Maybe I'm just going to put 14 divided by 3 equals 12 remainder. I don't know what, I'll just, yeah, be a remainder £2, but that's fine for you working out. Work out the money that's left over. 4 badges at £2.99. So what's £4, what's 4 times £2.99? Well, I'm gonna do 4 times £3 is £12, right? I need to take off all these 1p's. 4 times 1p is 4p. Take that off £12, you get £11.96, right? So £4 times £2.99 must be £11.96. Want to know how much money I've got left over? So from that £14, £11.96 of it I'm going to spend on those 4 badges. What's left over then? So what's 14 minus £11.96? Again, I think this is probably much easier to work out in your head. So it's 4p to get to £12. We've got to £12, £13, £14 is £2. So it's £2, 4p. Make sure you write 2.04. It's not 2.4. 2.4 is £2.40. Okay, next question. Hey, Taylor performs in a show. Taylor spends 1/8 of the show singing, quarter of the show dancing, the remaining 55 minutes backstage. Work out how long the show lasted. Right, okay, so let's look at the fraction of the time that Taylor spent singing and dancing. What's a quarter plus an eighth? Quarter, no, yeah, a quarter plus an eighth. We need our denominators the same again. Lowest common multiple of 4 and 8 is 2. So I'm just going to times that by 2 and times this by 2, which gives you 1/8 plus 2/8. Nope. Made up a symbol there, plus 2/8. Which gives you 3/8. So 3/8 of the show was spent singing and dancing. So what's remaining? 5/8. So 5/8 of the show is the remaining 55 minutes. I'm just going to kind of show this with a little diagram here because it's not the easiest thing to work out. 1, 2, 3, 4, 5, 6, 7, 8. So Taylor spent 1, 2, 3, 4, 5/8 of the show. The remaining show represents as 55 minutes, right? So if 5/8 represents 55 minutes, 55 divided by 5 gives you 11 minutes. So each part, like, of this fraction, this eighths, is 11 minutes. So all of these are 11 minutes as well. So can you say 11 times 8 represents the whole show, which is 88 minutes? Um, 60 minutes is 1 hour. So 1 hour takes you to 60 minutes. There's 28 minutes left. 60 to 88 is 28 minutes for your 5 marks. Complete this identity. Okay, so we're filling in the, so I'm going to work out what we've got here already. 14x minus, this is really easy to make a mistake, and I'm going to expand these brackets here. Minus 6 times x is minus 6x. Minus 6 times negative 2 is positive 12. Most people there would have put negative 12 if they did expand your brackets. It's negative times a negative is positive. Okay, right, so let's just simplify that. 14x take away 6x is 8x. So this is 8x plus 12. Want to make this equal to this over here. So I know it's going to be an 8x. So if I expanded these brackets, that's going to have to be 2 because 4 times 2x is 8x. Okay, let's just expand these brackets here now. I've got 8x plus 4. How do I make this 12 into this 4? Because I need to make them equal. I need to take off 8. So those are your missing numbers, 2 and 8. Vector A is 3, 2. So the top of the vector represents the positions moving right or left. Positive is right. The bottom is up and down. So that means 2 up, down would be negative, left would be negative. So I'm going to start here. You need to do this with a ruler. I don't have a ruler on this PDF. So 3 across, 1, 2, 3, 2 up. The vector would finish here. So I need a ruler. Straight line between these 2 points and my arrows here. That represents my vector A. On the grid, draw the vector A plus B. I need to add vector A and B first. How do I add vectors? What are the rules? I'll just add those top 2 numbers and the bottom 2 numbers, which will give you 3 add 1 is 4. 2 plus minus 4 is the same as 2 take away 4, which is negative 2. I'll start my vector here. This means 4 right, 2 down. Doesn't matter where you start your vector. 1, 2, 3, 4, 1, 2 here. Make sure you put an arrow on it. That's my vector A plus B. In the diagram, line AB is parallel to ED, so angles and parallel lines. What are we looking at here? Z, alternate angles, F, corresponding angles, or C, co-interior angles. Let's just put anything on the diagram we know. Those opposite angles are the same. Okay, X, so now I've just spotted we've got a Z angle or an alternate angle. So these angles here are the same. So that's X, that's Y. I'm just thinking this is a triangle. I know angles in a triangle add up to 180. It's 180 minus 45. Okay, well, it's 5 to get us to 50. And then another 130 to get us to 80, so 135. You could have used a column subtraction there. You would have got the same answer. Right, so this is shared in the ratio 3 to 2. We've got 3 parts here, 2 parts here, 5 parts in total. 135 divided by 5. Could use a bus stop method here, perhaps. 5s into 1, can't do, carry the 1. 5s into 13 is 2 right, because 5, 10. Remainder 3. 5s into 35 is 27, so each part of this represents 27. Okay, so this is X, this is Y. You want to know what X is. We're not really interested in Y, but this would be 54. So what's 27 times 3? You might have your own multiplication method you use. I'm going to use this one. 7 times 3 is 21. Put 1, carry the 2. 2 times 3 is 6, 7, 8, 81 degrees. A sphere has a radius of 3 centimetres. Calculate the volume of the sphere. Give your answer in terms of pi. Oh, we're given the volume of the sphere. Don't need to remember that. Our radius is 3 centimetres. 3 cubed, 3 times 3 is 9, times 3 is 27. So 4/3 times pi times 27. I would, so this is just from experience knowing this, that I would maybe change this to a fraction by putting a 1 underneath it. I think the best way of doing this now is to simplify before you multiply. So you look at your 3 and your 27, they've got a common factor of 3, so you can divide both of those by 3. 3's into 3 is 1. 3's into 27 is 9. I've like simplified those. 4 times 9 is 36. 36 times pi is 36 pi. So it's 36 pi over 1, which is just 36 pi. Now, these are the questions that now appear in the higher exam as well. Anything on from here is quite difficult. Okay, so cross-section of a prism. So how do you find the volume of a prism? You might be given this on your formula sheet. To get the volume of a prism, it's the area of the cross-section times by the depth. So let's just, what's this shape here? It's a triangle, right? So think about area of a triangle. Half base times height. Okay, right. Now let's have a look at this then. Okay, so B is 6. This is what the student's saying, B equals 6, which means height's 4. The base is 2 centimetres longer than height, so that works, right? But then he's saying that the volume is 6 times 4 times 10. But this is a triangle. How do you get the volume of a triangle? It's base times height divided by 2. So it wouldn't be 6 times 4, would it? It'd be 6 times 4, which is 24 divided by 2 is 12. It'd be 12 times 10, which is 120. So the error is not halved cross-section. I'll just tell you what else they have for that answer. Look at the mark scheme. So they said, oh, half omitted from the area of the cross-section. Sometimes they have extra explanations. You can have no, it's something along those lines. No, okay, right. What is B? So we know half base times height times 10 is 240. I'm going to divide both, no, I'm going to times both sides by 2 first to reverse this half. So if I times both sides by 2, reverses the half. So I get base times height times 10 is 480. Now I'm going to divide both sides by 10. Base times height is 48. Let me think. What numbers do I know that multiply to give 48? 6 and 8, right? 8 times 6 is 48. And the base is 2 centimetres longer than height. Yeah, that works. So your base is 8. Okay, scatter diagrams. So when you're plotting with these, you've just got to make sure you scale. You work out the scale. So let's look on this x-axis for age. Right, 1 is in half in between 0 and 2. So this is going up in 0.2s here on your x-axis. And here, so this is going up in 0.02s because it'd be 0.42, 0.46, 0.48, no, 0.42, 44, 46, 48, 0.5. So 5, 1.14. You've got to be really accurate. If you don't get it in the right place, you don't get your marks for this. 1, 2, 3, 1, 2, 3, 4, 5. Oh no, I need between 4 and 5 though. Don't between 4 and 6. 1, 2, 3, 4, 5. So that's 5. We go up to 1.14. So that's 1, 1.12, 1.14 there. 7 and 1.24. That's 1. No, that's 1. 1.12. Oh no, I need to go to 1.24, don't I? Sorry, this is making my eyes go funny. 1.2, 1.22, 1.24 is there. 9, 1.26. There's 9, is it? 1, 2, 3. No, it's not 9's there, sorry. 9 and 1.26. That's 1.2. I'll just do it from 1.2. 1.22, 1.24, 1.26 is there. 14. 1.68. That's 1.6. 62, 64, 66, 68 is there. Describe the type of correlation. Well, as the age of the student, of the children is increasing, so is the height. So we say positive. One of these children is taller than expected of their age on the scatter diagram circle. Can you see this anomaly here? It's this child. Kai's 8 years old. By drawing a line of best fit, estimate Kai's height. Right, I need a ruler for this. I'm going to snip it. Right, it's a line of best fit. Does not have to go through this bottom corner. It has to go through most of your points and follow the same general direction of your crosses. Sorry, I'm going to start that one again. Doesn't have to, right, there's another common error. It doesn't have to start from the first point or this point here. Just, sorry. I'm just going to, right, okay, so that's following. No, still don't like that line. Right, this follows the, right, that's better, but it's not a ruler. Right, we'll get there eventually. Right, here we go. I'm going to move it down a bit though, I think. That's following the general direction, but you need to have like half your points on one side, half your points, and that's better. 1, 2, 3. 1, 2, 3, 4. Move it down a little bit more. 1, 2, 3, 4. Yeah, that works. Okay, you can extend it throughout your whole diagram. There we go. Let me just see the mark scheme here. Let's just see. Ruled line of best fit. Okay. There we go. So make sure you do it with a ruler. That's quite important. Okay, Kai's 8 years old. Estimate Kai's height. Let's go back to my line of best fit. 8 is here, and actually show on the diagram. Just show the examiner you've actually used your line of best fit. Would take me over here. To 1.22, 1.24. His height would be 1.24 using my scatter graph. Describe an assumption you made in giving your answer. Well, I'd say is that all children follow this pattern. Let me just check the mark scheme. The child will fit the average pattern, will not be too tall or too short for their age. The child fits average pattern. Okay, explain why using the data to estimate the height of a child that is 17 years old may be unreliable. Go back to our scatter graph. If you look at the age in years, it doesn't actually go up to 17, doesn't it? So only have data up to age 14 out of the data range. Right, I'm going to look at the mark scheme again because there's quite a few different things you can have for this one. You could say the trend may not continue. The line of best fit should not extend beyond the data provided. Outside range of data provided, small sample. You could have also just said it's a small sample. What you cannot accept is this 17 is not on the graph, or the graph does not go up to 17 alone. Okay, trigonometry, SOHCAHTOA, opposite, hypotenuse, We're not going to label this because it's got no information on it. SOHCAHTOA, what uses O and H? Sine. This is without a calculator, so you need to know. You should have been given a list of sine ratios you need to know, and sine 30 you need to know is a half. So we know sine 30 equals opposite over hypotenuse. Okay, now you may have been given one of these triangles as well. Sine 30, opposite goes at the top. Oops. Well, opposite, I would put it as A. I'm just going to call it O. And hypotenuse is here. I'm going to show you using both methods. Let's just put it into our formula. Sine of 30 is a half. So we know a half is equal to O divided by 14. I times both sides by 14. Half times 14 is 7. So O is 7, or which is my opposite is 7, which is my A. You could have done it the same way here, using this triangle if you do use this triangle. Unknown at the top, sine of 30 is a half, 14. You're multiplying them. They're next to each other. Half times 14 is 7. Factorize. So to factorize a quadratic expression, you should be thinking, well, I need double brackets. That's your first thought. You need two numbers that multiply to get 24. Two numbers add to get 10. Okay, think about all your factors of 24. You got 1 and 24, 2 and 12, 3 and 8, 4 and 6. Okay, 1 out of 24 is 25. No, they add to get 14. No, they add to get 11. No, they add to get 10, 4 and 6. That's going to be a 4, not a 9. So it is 4 and 6. 4 times 6 is 24. 4 add 6 is 10. So it's x plus 4, x plus 6. If I expanded those brackets, you'd get this expression here. Write down the solutions that make this quadratic expression equal to 0. We've already factorized it. So you know this x plus 4 times x plus 6 equals 0. Two things to multiply to get 0. One of them has to equal to 0. So either this equals 0, that x plus 4 equals 0. X would have to be minus 4, right? Because minus 4 plus 4 is 0. Or same thing here, this bracket was equal to 0, x would be minus 6. Minus 6 plus 6 is 0. Those are your two options there. Okay, two more questions. A volunteer packs boxes for charity. They could pack 5 boxes in 45 seconds. Okay, so 5 boxes in 45 seconds. I'm going to think, right, well, how long does it take for one box? Divide by 5. 45 divided by 5 is 9. So we're going to say one box is 9 seconds. So what would it be for 55 boxes? Okay, 9 times 55. Then it's up to you how you do this. I'm going to do it like this. 5 times 9 is 45. Put the 5, carry the 4. 9 times 5 is 45. Add 4 is 49, so 495 minutes, we're going to say. No, seconds. That's seconds, isn't it? To compare them, I'm going to have this in seconds as well. So it's 9 times 60. 9 times 6 is 54, so it's 540 seconds. So yes, they can, can't they? Because that's less than 540 seconds. What assumption did you make? They packed at a consistent rate. Packed at the same rate. Let me just give you the alternatives you could have had for that. Took no breaks. Pack for 9 minutes without stopping. Each box took the same amount to pack. They don't get tired. They were not interrupted. Boxes remain the same size and consistency. They won't make any mistakes. I assumed every box took 9 seconds. Anything along those lines? Okay, last question. A student draws two different regular polygons. The exterior angle, right? There's quite a lot of formulas you need for angles and polygons. Exterior angle. What's your formula for exterior angle? You will not be given these, by the way. Exterior angle equals 360 divided by the number of sides. I'm guessing we're going to need that. The sum of P and Q is 112. So we know P, the sum means you add them together. That's what we know. The difference means you subtract them. So this is what we know. Okay, this is now simultaneous equations. Right, what do we do with simultaneous equations? I check to see if these are the same. Got 1Q, 1Q. Because you've got a plus and a minus, the signs are different, we're going to add. Okay, so what is P? 1P add 1P is just 2P. Q, add negative Q, disappears. 112 add 32, 144. Okay, divide both sides by 2 now to isolate our P. So 1P is 72. Okay, now I'm going to use this expression here to work out this, equation to work out what my Q is. P is 72. We know 72 minus Q equals 32. So what you take off 72 to get 32, it's just 40, isn't it? So Q is 40. Not finished yet though. We need to work out the number of sides of each polygon. So we know this is the exterior angle for one polygon. This is the exterior angle for another. Let me just take this one first. Okay, so exterior angle is 40. 40 equals 360 divided by n. I'm going to times both sides by n to get 40 times n is 360. Divide both sides by 40 and we get n is 90. No, it's not, it's 9, sorry. 360 divided by 40 is 9. So that would have been a bit crazy, a 90-sided polygon. This is a 9-sided one, so it's a nonagon. There we go, 9. Okay, next we are going to do the same thing for 72. Don't think it's going to be quite as easy to work out this though. Times both sides by n. Divide both sides by 72. Right, how many 72s are there in 360? I'm just going to go up in 72s. 144 plus 72 is 216. 288. Yeah, 288. Hoping the next one's going to be 360. You could write down the sum down the side if you want. Yeah, it is 360. 1, 2, 3, 4, 5. So we've got a pentagon. 5 sides. Okay, that's it. So is there anything from here that you feel like you need more practice in? On my YouTube channel, if you just write a little note and I can attach a link to like little revision videos on each of these questions, if that is useful. Okay, thank you.